Okay, this video is for my geometry students. Sections 1 through 8 are going to be covered on this, and again, your test on Monday covers all the sections from Chapter 1, so make sure if you need a refresher that you find the first video and watch it again. So in this problem, we're going to construct angle y, so that the measure of angle y is half the measure of angle A. And I have provided you with angle A here. So the first thing we're going to do in this problem is we're going to, I'll put part A, we're going to bisect angle A. The reason we bisect angle A is to figure out what half of it is, okay? Because that's what y has to be. Y has to be half of A, and a bisector splits an angle in half. So the first thing we do, and hopefully you can grab your compass and protractor, the first thing we do is we're going to measure from A halfway down the side. That's our compass. And we're going to make an arc going in the angle, just like that. So I took my compass, put it on A, and did this arc. So now I have 2 points that are equal distance from A. So then the second part is, and I'll use bright blue, I'm going to put the point on these 2 intersection points. So these 2 points are important now. And I'm going to do an arc here and there. So I put the compass, and you don't have to change the setting. I told you did in class, but you don't have to change the setting. You put the point on these 2 points, and you make arcs out in the middle of the angle. And this intersection point gives you the point on the angle bisector, and you connect them. And now this angle is congruent to that angle. So now I know that this right here is half the measure of angle A. So now part B is now I have to copy half the measure of angle A. I have to copy this angle, and we did that in class as well. So let's talk about how we copy the angle. Well, first thing is I need a side to work with. So there's my side. And this point is going to be y. And hopefully this little piece right here, this half of angle A, is going to be what is on this side with y. So now I open the compass halfway down the side. So this is going to be maybe confusing. Okay, so from here to here, open your compass up, and I make an arc. And again, make sure the arc's long, because there's going to be a side that goes through that arc. Now, step 2 in this process, and I'll use purple, is now you have to take your compass and open it up as wide as that arc you just made. So we had an arc here. We copy that arc over here. Now we have this point here and this point here. We need to measure that width. We need to measure that width right here, this purple width. And we need to put our point here, and we need to draw an arc right there. That gives me where that second point's going to be and where this ray is going to go. And hopefully your angle y looks half the measure of angle A. Okay, so I did my best. Sorry if that was confusing. It's very hard to describe these over the internet without tools, but hopefully you could follow along and construct angle y. Okay, so in this problem, I'm giving you 2 points, A at -3, -4, and B at 5, 5. And you're in charge of finding AB, that's the length of AB, or the distance between A and B, and the midpoint. So, part A, we start with the distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's, again, all in a square root. So we need to fill in these numbers. So the distance is AB. That is x2. And you can label the points like this. You can go x1, y1, x2, y2. Let me scoot that down so you can see. Just like that. So just label your points. And fill in your numbers. 5 minus, and x1 is -3. Notice that I put the 2 negatives next to each other. Plus 5 minus -4. Now we do our plus plus. 5 plus 3 is 8 squared. We do our plus plus. 5 plus 4 is 9 squared. This is 64 plus 81. That is the square root of 145. And just plug it in your calculator. That's all you got to do. The square root of 145. 12, and it does not round, 12.0. And that's fine. 12.0, and that's the distance AB. So AB is 12.0. The 4 does not make the 0 turn into a 1, but I still want one decimal place, so 12.0. Okay. Notice at this step, remember at this step, when you're squaring things, remember it turns positive. Do not be that person that has negative numbers down here. No, when you square, it turns positive. Don't trust your calculator. Use your brain. Use your brain. Okay, now I got to slide down. I'm going to go back and forth because I need the coordinates of A and B. So let's see. I'll do it right down here. So the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. Remember, it's just the average. So I'll copy right here. So the midpoint, and then I'll work down. The midpoint is going to be negative 3 plus 5 over 2, and negative 4 plus 5 over 2. Okay, so let me slide this down so we can see. And I'll do my work over here now. So negative 3 plus 5 is 2 over 2. Negative 4 plus 5 is 1 over 2. So this is 1 and 1/2. That's a good answer. If you are a decimal person, you could also put 1 and 0.5. Either answer is acceptable, but here's how you find distance and midpoint. Okay, so here, this problem is the midpoint of segment AB is 5, negative 8. Given A, find B. Given A at negative 2, 8, find B. So here's one of those find the endpoint problems. Okay, so remember, there's two ways. There's the algebra way or the graphing way. And remember, the graphing way involves the slope. So either way is acceptable. So we are going to do it the algebra way. And the algebra way consists of using the midpoint formula. So the midpoint formula, as we wrote up above, is x1 plus x2 over 2, y1 plus y2 over 2. Now, we know that A is negative 2, 8. So let's call that x1 and y1. B we don't know. So let's call it x2 and y2. We don't know. And this up here is our midpoint M, 5, negative 8. So this formula is going to equal the midpoint of 5, negative 8. So let's fill in what we know, and let's try to set up some equations, right? That's algebra. So we know x1 is negative 2. So for this midpoint formula, negative 2 plus x2 over 2. We don't know what x2 is, so we leave it as x2. x1 is, or y1 is 8. 8 plus y2 over 2. This is going to be our midpoint, 5, negative 8. Let me slide this down so I have more room. And now we take this and set it equal to 5. Negative 2 plus x2 over 2 equals 5. And the other one I'll do it a different color. We'll do yellow. And then we do 8 plus y2 over 2 equals negative 8. Okay, so the x goes with the x, the y goes with the y. And we solve. And we solve. So first thing I would do, times by 2. Get the denominator gone. Negative 2 plus x2 equals 10. And then we'll add 2. This is an add 2. It's an add 2. So we have x2 equals 12. So there's the x of my B point. It's 12. Now let's do the same thing over here for the y coordinate. Times 2 times 2. The 2's cancel. 8 plus y2 equals negative 16. Let's subtract 8 from both sides. We get y2 is negative 24. So the final answer for what B is 12, negative 24. Again, you can use a graph, you can count the slope. I think I provide the graph on the test for you, so you can do either method. I don't care. Okay, but both are good. Make sure you show work. Okay, here is our next problem. Hopefully you can read it. It says, what is the area of a section of pavement that is 20 feet wide and 100 yards long? Give your answer in square feet. I hope you see these words square feet. This is area. It is it's a rectangle because it's a wide and long, length and width. So it's length times width. But I hope you notice that the one is 20 feet. That's the width. And the length is 100 yards. You can't mix different units. We need this final answer to be in square feet. So this 100 yards, you need to convert. Well, 1 yard is 3 feet. So if I have 100 yards, that's 1 times 100. So to get the number of feet in that yard, I have to do 3 times 100. So the length we need to use is 300 feet. There's 300 feet in 100 yards. Now I can come back over here and use my equation. The length is 300. The width is 20. So the area is 0, 0, 0, and 6. 6,000 feet squared. Now, just to practice, what if I talked about the perimeter? Okay, let me slide it down a little bit. You don't need the whole problem. So for a rectangle, the perimeter is 2L plus 2W. So I'd plug it in. 2 times the length plus 2 times the width. That's 600 plus 40. So the perimeter in this problem would be 640, and that's feet. Not feet squared, but feet, because it's perimeter. And again, to do a perimeter problem, you need the units to be the same as well. Here's our next problem. It's a simple problem, but I just want to go over the wording again. So given a circle with a diameter of 7 inches. So again, you don't need to draw a picture, but over here I'll just do a quick sketch. Diameter goes all the way across. That's 7 inches, and there's the center. Find the circumference, round to 1 decimal. So part A, if they give you the diameter, use the diameter equation, pi times diameter. So we just fill it in. Pi times 7. Again, do not use any approximation other than the pi button. And if I round to 1 decimal, that actually rounds up to 22.0. And that's inches. Every answer has units. So that's A. That's the circumference. Now, the B, find the area in terms of pi. Well, there's only one area formula, pi r squared. We need r. Well, we have the diameter. We need to know that the radius is half the diameter. So the radius is half of 7, which is 3.5. There's our radius. So area equals pi times 3.5 squared. We need to remember that you have to square the radius. So in the calculator, I'm going to square the radius, 3.5 squared, and I get 12.25. This, in terms of pi, remember, means do not multiply by pi. So I just do 3.5 squared, which is 12.25 pi. Just write the pi next to it, and that's inches squared. And there's these 2 problems. I'm very proud of this problem because I created it myself. It's a great problem. So here you go. Here's this figure. We need to find the area of this figure. Okay? Well, I've kind of already partitioned it a little bit for you. It's not regular by any means. So we need to break it down. And I've given you this breakdown. So notice that right here, this is a quarter circle. Okay? I'll write the word. So when we find the area, we only need to take 1/4 of that area. Okay, so we'll talk about that later. Then if I draw this dotted line, now I have so this would be called area 1. Here we have a rectangle, area 2, pretty basic, 5 by 12. And then we have area 3. Well, if this is 5, that's 5. And what about here, from here to here, the base? What are we going to call this? Well, if the whole thing's 20, from here to here is 12. This is 5. This is also 5 because they're both radii of the circle. So 5 and 5, that's 17. So what's left over from here? Well, 20 minus 17 gives me 3. This right here is 3. Okay? So now I have all the dimensions I need to find my areas. So I will use 1, 2, and 3 in my area formulas. Area 1. we have to use the circle formula, pi r squared. But we only want a fourth of it. So we're going to take 1/4 of it. So what I would do is I would find the area and then just take a fourth of it, or divide it by 4, right? That's a fourth. So it's 1/4 times pi. R is 5 squared. So in the calculator, I do 5 squared times pi. So I'm not going to round yet. I'm going to leave my calculator, but I'll write down what I got so far. You get like 78.53 something. So then times that by a fourth or divide it by 4. Either one works. And we'll round that to 1 decimal place. And that's 19.6 centimeters squared. So there's area 1. Area 2 is easy. Area 2 is just length times width. 5 times 12, that is 60 centimeters squared. And now what about area 3? Let's use blue. Area 3, the triangle. Well, area. That's hard to see. I'll use light blue down here. Triangle is 1/2. Base times height. That's 1/2 of my base of 3 and my height of 5. That's half of 15. Half of 15 is 7.5 centimeters squared. So I have all my areas that make up this figure. I need to now add them together. Area total equals 19.6 plus 60 plus 7.5. So the area total, 19.6 plus 60 plus 7.5, is 87.1, and that is centimeters squared. All answers have units. That's a great problem. Okay, so you're going to have to do some drawing on this test. Okay, so instead of having a picture, I'm going to have you draw. So here's what I want you to draw. I want you to draw plane ABC intersecting plane ACM. And I want you to draw a line L that's perpendicular to plane ABC at C. Okay, so let's see if we can draw this. So remember that drawing those intersecting planes is not easy. So start with a plane going sideways. Let's not name anything. Let's not put anything. It's going to be plane ABC, but I see A and C and A and C, so that should be ringing a bell in your heads about something special about those 2 points. But we'll get to that. So that's the first plane, and I have the beauty of having a second color. So there's my second plane. Okay. So hopefully you drew as best you can. And again, if you want to do some dotted techniques, right? So pretend this plane's in the background there, and this plane's underneath there. Undo that last one. You could also shade if you want to. You know, you could shade this red. Right? You could shade that red. We should also draw the intersection line through here. Right? That's important. Okay? Alright. And again, so this would be red as well, because the blue's behind. And then the blue would be blue here and down here. So again, if that helps you, I don't know. Okay? So you can shade or you can dot. So now, because the two planes have A and C in common, A and C need to be on that line of intersection. That's the trick. Okay? A and C. Now I want to change this. I'm sorry. I need to change the original problem. I didn't mean to put C here. I meant B. I apologize. So fix that up. So we're going to make that B. So then on the other planes, we need to just put some random points somewhere. So on the red one, let's call the red one ABC. A and C are there. Let's put B way out here. There's point B. And on the blue one, here's ACM. Let's put M up here. Okay, so there we go. So there's B, there's M. So now I need to draw a line L perpendicular to plane ABC at B. So the reason I changed it to B was because I didn't want it to be this line. I want it to be here. So let's go with orange. I'm going to draw a line that goes straight down through B disappears, and then comes back out the end there. And we're going to call this line L. And to show that it's perpendicular, I'll put a right angle box right there. And there's a great picture of two planes intersecting. They share two common letters, so that's the two letters on the line of intersection. And then another line perpendicular to the third point on that plane. Very good. Okay, so make sure you practice drawing planes. It's going to be very helpful. Okay, this is the last one, and it's a very tough one. Remember, we talked about this in class when we went over your homework, an algebra problem involving two angles. So it says the measure of an angle is 6 less than 3 times its complement. Oh, what are the two angle measures? First thing, you have to know there's two angles involved. The first angle, we call it x. Now, the second angle is the complement. Okay? So, to represent the complement, we need to know that a complement is the number that you add to x to get 90. Well, another way to do it is if you have the one angle, subtract it from 90, and you get the complement. So remember, the supplement is 180 minus x. So now we have this equation. The measure of an angle, that is x. Is means equals 6 less, and let me scroll this down so you can see what I'm doing above. 6 less than, that's subtraction. But it comes after. 6 less than 3 times. 3 times means multiplication. So 3 times its complement. Its complement is this guy, 90 minus x. After we take 3 times it, we then take away 6. And there's our equation to find x right here. We're going to be able to find x, then we'll find its complement. Okay? So we have to get good at the algebra. All right, so first thing I would do is I would distribute the 3. 270 minus 3x, and then the minus 6 comes down. Then I would combine the 270 and the minus 6 because they're on the same side. This is 264, sorry. 264 minus 3x. Let me scroll down just a minute. Now I'm going to add 3x on both sides to combine my x's. Here's where I'll bring it up here. So when we add 3x to both sides, I get 4x equals 264, and divide by 4. X equals, that is 66. So what is the measure of the first angle? The first angle is 66 degrees. Now to find the second angle, I take 90 minus 66, and that is 24 degrees. And the magic of mathematics, 66 and 24 is 90. And if I take 24, times it by 3, and subtract 6, that is 72 minus 6, which is 66. It's all very magical, this beautiful subject we learn, mathematics. So hopefully you understood these 8 problems. Bring it to class for bonus, and you study your butts off for this test on Monday. We'll see you on Monday, or my White Block kids on Tuesday. Great job. Thanks for watching.